Welcome to Problems. So, welcome to problem solving session of Introduction to Polymer Physics. So, welcome to a problem solving session of the course Introduction to Polymer Physics. So, before other people join into this session, like I will go into the week zero questions. I think you guys would maybe by this time you would have went through these questions. So I will just quickly go through each one of those. So the first question goes like this. So which of the following is a branched polymer? So whether it is a low density polymer or a polyester or a high density polymer or a nylon. So if you look into the structure of nylon, it would be almost like networking structure, whereas high density polymer will have like comb like structure. Polyester, of course, it's a kind of linear structure, whereas the low density polymer will have a branched polymer structure, something like this. So coming to the second question. So on the basis of mode of formation, polymer can be classified as whether it is only based on addition polymers only, or condensation polymers only, or copolymers, or both addition and condensation polymers. So this is regarding formation or the mode of formation by which polymers will be made. So it is of two types. One is the addition and another is the condensation polymers. So we'll move on to the third question. So in addition polymers or in addition polymerization, monomers used are whether they are unsaturated compounds or saturated compounds, or a bifunctional saturated compounds or trifunctional saturated compounds. So they can't be a saturated compounds to participate as a monomer in a polymer. So there has to be an unsaturated compound, so that and these compounds will act as a monomers to go into polymerization in an addition polymerization. So coming to the fourth question. Polymer formation from monomers starts by I mean, it's somewhat related to this question as well, but somehow if you look into the options, like the hydrolysis of monomers is nothing but like breaking of monomers, whereas like it can't be the conversion of monomer to monomer ions, by protons. And it also can't be a coordinate reaction, because it may be a reaction coordinate between a monomer. So these three options can't be the right solution to this question. So the option goes with the condensation reaction between the monomers. So coming to the next question, like which of the following does not undergo additional polymerization? So the option goes like this, like with the vinyl chloride or butadiene or a styrene. So if you look into all these monomers, they will undergo addition polymerization, and so the right option would be like all of the above, which undergoes addition polymerization. Coming to the next one. So under the following, which of the monomers are unsuitable for condensation polymerization? So if you look into all of these monomers, and also like the polymerization of these monomers into to make polymers, only these two will be different compared to others, because they undergo like addition polymerization, whereas all these goes to condensation polymerization. So coming to the next one, which of among the following polymers have low solubility, whether it is polyethylene, polystyrene, nylon 6 or epoxy resin? So maybe all of these three may have a good solubility, but whereas epoxy resin is called as like very highly insoluble polymer. So coming to the final question of week 0, which goes like this: the process of heat softening or molding and cooling to rigidness can be repeated for which plastics, whether it is thermoplastic or thermosetting plastic, or both A and B, or A or B. So here like the question is about like heat softening, molding and cooling back to its rigidness. But if you heat a thermoplastic, it won't go into the previous structure, whereas that is possible with the thermoplastic. Maybe for a thermoset plastic, you can think of a egg yolk. If you heat it, like it can't be reversible, whereas a thermoplastic, any kind of plastic material can somehow come back to its original state again. So the answer goes with the thermoplastic. So these are all week 0 questions. Of course, like the answers to these questions are available in the portal itself, and I would like to highlight here like what is this problem solving session is all about. So this session is mostly about for the people who are find difficulties in answering assignment questions. Of course, like it's like the so it doesn't mean that like we'll provide some solutions to the assignment problems, but whereas like here like mostly I will try to suggest a way so that the candidates can able to answer the assignment questions well. So that's of course one priority for this problem solving session. And maybe you can also expect like if you are not able to understand any concept in the current week or the previous weeks, of course you are well appreciated to get those difficulties to this session. But for this, like, I would recommend you to go through the videos at, at least twice, and then if you're still not able to understand, yeah, there are two ways. Like, one is attending this problem solving session, or there is one more way also to without waiting until the weekend, or this Monday around like 7 to 9, you can also post this question uh, in discussion forum. So that's also one way to get clarify, or get the clarity with the topic which you haven't understood well. And of course, like, once these things are of course, like, this will be given a high priority and then followed by this. And if still, like, if there is a time, like, you can ask any of the relevant questions regarding to this particular area. And I recommend you not to go out of the topic, because in this, like, polymer area itself, it's vast. And yeah, if time permits, like, if the session was free, like, we'll try to address those questions as well. But yeah, that is all depends on the number of participation, and that is all about the session. And this will happen every Tuesday, 7 to 9. And it will mostly, like, there won't be any change in the link. And you will get a reminder one day before. Mostly on Monday you will get a reminder for this session. So in this, like, 2-hour session, like, we'll initially, every week, like, I would like to come up with some sample questions that make you to solve these assignment questions, or help you to answer these questions well. And maybe I will take, like, initial say, like, 30 to 40 minutes to show these sample questions and maybe solve, or to give solutions to those questions. And then after this, after like 40 minutes to rest, it's all about discussion, anything related to what I have discussed before. It can be related to the topics which you haven't discussed, and I suggest you to come up with your problem, and then discuss it freely at this problem solving session. That's all about, like, what actually happens in a problem solving session. And without wasting the time, like I will go into the sample questions. So the first question goes like this: what's the units of diffusivity? So of course, like it's basically in this kind of areas, like diffusivity is proportional to square root of mean square displacement divided by time. So that's what, like it has a units of length square divided by time. So this goes with this. So coming to the second one, dendrimers are highly branched structure, whether it is true or not. So the dendrimers are something like this. Yes, these are like highly branched. So the answer is like true. So coming to the third question, like diffusion coefficient is proportional to what? Whether it is proportional to the number of segments in a polymer, or the segment concentration, or end-to-end distance, or the slope of mean square displacement versus time. Well, this is how like the diffusivity will be measured if you especially in molecular dynamics. That is like change in mean square displacement divided by change in time. Of course, this divides with some factor. It depends on again it depends on number of dimensions and also the phase space. So in the current discussion we don't bother about this, so directly D is proportional to change in mean square displacement and change in time, which is nothing but slope between mean square displacement and the time. Mostly it will be like this, not like this. Initially it will be 0, and through time, like the mean square displacement will keeps on increasing. So coming to the fourth one, the system contains 5 chain of molecular weight 1000 and 5 chains of molecular weight 2000. What would be the number average molecular weight? So as you know about the number average molecular weight, which is summation of number into molecular weight divided by summation of n. So if you sum it, it is like 5 into 1000, then 5 into 2000 divided by 10. That comes around like 15,000 divided by 10. That is around 1500. So the number average molecular weight is around 15,000 for this system. So coming to the next one, the number of intensive variables required to fully characterize water at a triple point. So if you look into the degrees of freedom from the welcome to this just give me a minute. Are you able to hear me? If yes, like you can give yes in the chat box. Yeah, thanks. Uh, so I was discussing about these regarding the problem solving session. So first I started with week 0 problems. Maybe you would have solved by this time. And maybe I have given some discussion about what this problem solving session all about. And currently I'm explaining some sample questions. So this recording will be available in the portal. Okay. So the number of intensive variables. Okay, then the question goes like this: the number of intensive variables required to fully characterize water at a triple point. We know that from the Gibbs equation of degrees of freedom, which is F is equal to C minus P plus 2. So it is about like how many intensive variables are required to fully characterize water at a triple point. So at the triple point, you will have all three systems available. So as water is one compound and there were around like three phases coexisting at a triple point, so you will have like F is equal to C minus 1 minus 3 plus 2, so that is equal to 0. You can see like degrees of freedom, and you don't need to there is no requirement of required intensive variables to characterize the water at a triple point. So the number of intensive variables required is 0. And coming to the next one, in a random walk models of a these random walk models of a polymer chain can be best described as a toy model. It's not an empirical model or an exact model. So coming to the next one, so whether rubber is the rubber is which of the following, whether it's a polymer network or an entangled polymer solution or a concentrated polymeric solution or a polymer melt. So basically rubber or any other like nylon or nylon 6 or nylon 66. So these are like networked structure which is of something like this. So it's a polymer network, not an entangled polymer solution or a concentrated polymer solution or a polymer melt. So the next one goes like this, which is the viscosity of a polymer solution goes with with the increase in the concentration. So what will happen to the viscosity of a polymer solution if you increase the concentration? So if you increase the concentration in a polymer solution, basically viscosity will increases with that, because of course with the concentration. So coming to the next question, like where the question is about molecular dynamic simulation, which involves which of the following, whether it is a velocity calculation or a force calculation or a random number generation or energy calculation. And all of these four options looks familiar if any one of you from a molecular dynamics, but but to do a simulations, what basically we need is only these two, which is velocity calculations and the force calculations. If you do the force calculations, like energy calculations comes from this, and random number generation, basically it will be used to define the initial configuration in MD simulations. So these are not mandatory, because there are many number of ways to define initial configurations, and of course like energy calculations comes from the force calculations. So this involves mainly with the force calculation and the velocity calculation, not with the rest of the two. And coming to the next one, like yield stress is defined as which of the following, whether like the stress beyond which the material is Newtonian, or the stress beyond which the material viscosity is constant, or the stress beyond which the material is no longer viscoelastic, and the stress beyond which the material starts to flow. So basically yield stress, you can think of like the stress which has to be applied, like consider like the real-time applications, like using the toothpaste. If the toothpaste has to come out, like you have to apply some stress, only then like the fluid will move. So that is basically a stress beyond which the material will starts to flow. So that's what the actual yield stress means. Up to that point there won't be any movement with the flow of the material, whereas after that the material starts to flow. And coming to the next one, what is like an ensemble average of end-to-end distance of an ideal polymer chain is proportional to. So ensemble average of end-to-end distance, which was defined by RE, which was proportional to. So we have seen in the videos or in the lecture videos, so and some of the mathematical derivations of these end-to-end distance were defined for and we can't define the average end-to-end distance, or the ensemble average of an end-to-end distance. It will be 0, whereas like square of end-to-end distance is possible. So that we end up with getting the relation is RE square is equal to MB square, considering that M is the number of segments, B is the length of the segment, and this is at all L is equal to M. And if you take this square off, so that will be proportional to square root of number of segments and then B. So under these following options, like you can see, like it is proportional to the square root of number of segments, whereas M is number of segments. And also like the molecular weight as end-to-end distance is also proportional to N, nothing but like number of repeating units. So this the ensemble average of the end-to-end distance of an ideal polymer chain is proportional to this both molecular weight as well as the square root of number of segments. So coming to the next one, the segment length in a random walk is the segment length in the random walk is how it is related to the actual system. So the segment length in the random walk is nothing but there is a drunkard as per the lecture, and he is taking one step to the left or one step to the right. So the segment length is nothing but the step size. So how this step size is related to the one-dimensional to the actual polymer structure. So whether it is like same as the carbon-carbon bond length, or the length of the monomer, or the length of the repeating unit. Length of the repeating unit or length of the monomer, maybe they are like quite similar, and the arbitrary length that may be represented represents several repeating units. So that's what it was considered in an ideal polymer chain. So it's not a single monomer, it's like some of the more number of carbon chains are considered as a single unit that is somewhat like arbitrary length that may represent like several repeating units. Repeating units is nothing but the monomers. So each step size here in a truncard walk is related to arbitrary length in the ideal polymer chain model. So this goes with this. Coming to the last one of this slide, which of these best represents the behavior of a polymer chain, whether it is a curved surface or a long straight line or a random walk or a cuboid. So the behavior of the polymer chain is represents this random walk. That's what we discussed in this particular problem as well. Coming to the further next questions. So for a one-dimensional random walk, the number of trajectories that result in a displacement of 2 steps to the right or left in 4 steps. So whether it is 12, 4, 2 or 8. So the question is quite simple, that as per the model, like, so there is a drunkard at the center, and consider like 4 points from this, like this is like first step to the left, second step to the left, and third step to the left, and fourth step to the left. Similarly, there is first step and second step and third step and the fourth step. When we are talking about the number of trajectories that result in the displacement of two steps to the right or to the left in a four steps, if you see the number of possibilities were there in such a way that the drunkard has to come to this first step is similar. First step to the left is similar to the first step in the right. So the number of trajectories were same for 1 and 1 as well as 2 and 2 and so on. So for this kind of problem, it would be better to look into the number of trajectories on one side, and then it's just if you look into the distributions of this kind of problems, it's like a normal distribution, and if you know this what is happening on one side, it's just the twice in the other direction. So coming to the problem and to understand well about it, it is nothing but the drunkard is making 4 steps, and out of which how many trajectories are possible in such a way that he has to be in the second step from his right or second step to his left. So the number of trajectories possible is as per the formula, 2 to the power m. So m is the number of steps, so 2 to the power 4 is the 16. So 16 ways are possible, out of which how many ways these drunkard will end up in making only end up in the second step, out of which he is making 4 steps overall. So you can check there is only one possibility. If you do it manually, there is only one possibility to end up in the 4th step. So overall there were around 16, and if you remove these two, it will become 14, and that is not the right way, I would suggest. So consider one side, and then there were around 4 steps. So to find the number of possible ways will be 4 factorial divided by number of steps he is making to the left, and number of steps he is making to the right. So this is how it will goes. So these two things can be defined, consider the right side as n minus. So these are the steps which he made towards the left, and n plus is towards the left. So you can write the equations from this, both the overall steps he is making is around only 4. So whereas what we want the drunkard has to be in the second step from his initial position. So it has to be n minus of n plus, it has to be 2 in such a way that he will end up in this point. So this is what will define n. This is as overall steps, and this is what d, we want the drunkard has to be in that position. So we can define this as from this the one will become n minus d by 2, and other will become n plus d by 2 whole factorial. So if you do that, it will become 4 factorial. It would be better if it would be 4 factorial divided by 1 factorial into 3 factorial. So that is 4 factorial. So 4 into 3 factorial divided by 3 factorial. So that is overall 4 ways. So this is towards left, whereas there will be another 4 ways towards right. So overall there are around like 8 trajectories that are possible in such a way that the drunkard will end up in 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 taking displacement of 2 steps in overall 4 steps. So this goes with this. So the 4 factorial is nothing but like the overall number of steps. So you can write like n factorial divided by n minus t by 2 whole factorial, n plus t by 2 whole factorial. So this is for one side, but whereas like the question is about either left or right, so the probabilities will add in both left and right directions. So coming to the next one, so whether rubber is an example of whether it's an oligomer or a polymer melt or a polymer solution or a cross-linked polymer. So as I have discussed before, like rubber is more of like polymer linkings will be there, so it's a cross-linked polymer. So coming to the next one, the degree of correlation between the carbon atoms of a polymer chain, usually what happens with the degree of correlations between these carbon atoms in a polymer chain. So usually so what the question is like within like the carbon chain. So when you consider this as a first position, and second and third and fourth and fifth, so what will happen between these carbon atoms when you increase the polymer chain? So these two will have high degree of correlations, which is like the bond length, whereas the second will have an angle and third will have a dihedral kind of correlations, and from the fifth it would be a negligible correlations. So basically it decreases with increase along the contour. The contour is nothing but a chain, so this having like small carbons, so it actually, the correlation actually decreases with the distance along the contour. So coming to the next one, which goes like this, what would be the so it's about like the quantum chemistry calculations which are typically not performed on polymers because of the following reasons. Whether it is like Schrodinger equation is not possible for polymers, or electrons are delocalized in the polymer, or these calculations are very time consuming, and toy models provide very accurate predictions of polymer properties or what. So if you look into these, like the toy models can't provide very accurate predictions. Maybe somehow like they will give some qualitative predictions about polymers. And coming to the electrons are delocalized in polymers, this is also not somewhat true. And coming to this, like the Schrodinger equation is not applicable to polymers, and this is also not true because Schrodinger equation can be applied to any kind of systems. But the only problem in doing these quantum chemistry calculations are like these are very time consuming, because it's very low level calculations. And if you look into the molecular simulations, like the quantum chemical calculations are kind of DFT, density functional theory calculations, or ab initio. These are like quantum level simulations, and there were something like classical level, and here like classical level simulations mostly are of like atomistic, and there were like higher level which is known as coarse-grained simulations. I'll simply write as CG. So in this level, both length and time scales keeps on increases. So that is the reason why, like in coarse grain simulations, like you can people will go with high number of the system size would be higher, and it keeps on decreasing when we go into more atomistic detail or kind of quantum level simulations, and it will be like very time consuming because it will be in very small, not even like lesser than nano or femtoseconds. Coming to the last two, there were one more question left. So when you can say a polymer is an oligomer or a polymer, so this is what represented in most of the polymer physics books. So if you want to say an oligomer, the molecular weight has to be less than 20, and if you want to say, if you have to say a polymer, this molecular weight has to be greater than 100. So coming to the last question of this session. So what is the value of PD, which is nothing but polydispersity? If so this is a normal, a real time example. Say consider like if there were 3 male candidates of mass 70 kgs and 10 females of mass 40 kgs. Like all these, like 3 plus 10, around 13 people were there in a room. So what would be the polydispersity? So we know like polydispersity is nothing but weight average molecular weight to number average molecular weight. So if you do that, like the weight average molecular weight is equal to 3 into 70 square plus 10 into 40 square divided by 3 into 70 plus 10 into 40. Of course this is male and this is female. So that's a weight average molecular weight. And coming to the number average molecular weight, that is around like 3 into 70 plus 10 into 40 divided by 30. Let me use my calculator. So 3 into 70. 7. And the number average molecular weight is 3 into 70. I think it's around like 16 divided by 13. So that is around like 46.923. So the poly dispersity is around 50.327 divided by 46.923. So that comes around 1.07. So this is a poly dispersity. Maybe you can consider it as a room like where 3 male candidates of mass 70 kgs and 10 female candidates of mass 40 kgs were there in a room. So this is all about the sample questions of week 1. So maybe one joined during the meeting, and maybe you can get these recordings in the problem solving sessions in the portal. Of course, that will direct you to the YouTube channel. And I'll wait if someone will join into the session or not. Maybe for some 30 minutes. Mostly it will goes like this, like in every week, like I would be taking around like initial 40 minutes for this sample problems, and then and the next and the rest of the time, like it's all about the discussion with the people, like if they have any specific doubts. So I think that's all for this week. sorry for that. Like at that time, there was an echo issue. So what happened in this session is like I started with the week 0 courses. I mean week 0 questions. I think you would have solved it before, and the answers were available in the portal. So after that, like I have given a small discussion about like what is this problem solving session is all about. So maybe let me. Okay. There might be a connection issue. Anyway, thanks for joining. So are you able to hear me? Looks like there is a connection issue from your side, but it's. You can give S in the chat box if you are able to hear me. Are you still connected? Again lost. we'll end up for today, and we'll meet in the next week with the week 2 sample questions. Of course, like there is a very few participation